Hey everyone, in this video what we're going to do is figure out what the limit is as x approaches 0 of x minus tangent of x divided by sine of x minus x. Now, if we were to just let this limit tend to 0, in the numerator we would have 0 minus tangent of 0, which is just equal to 0, and in the denominator we would have sine of 0 minus 0, which is also just equal to 0. So our limit is of the form 0 over 0. And in order to evaluate it, what we're going to have to do is use something called L'Hopital's rule. L'Hopital's rule basically says that if you have a limit as x approaches c of a function f of x divided by another function g of x, then that limit is equal to the limit as x approaches c of the derivative of f of x divided by the derivative of g of x, given that f and g are both differentiable at c and that the limit is of indeterminate form 0 over 0, or plus or minus infinity divided by plus or minus infinity. And we can also apply this rule indefinitely as long as that criteria is satisfied. As that criteria is satisfied for this problem, let's go ahead and apply L'Hopital's rule to see if we can solve it. So we're going to have the limit as x approaches 0. Now the derivative of the numerator is 1 minus secant squared of x, and this is divided by the derivative of the denominator, which is just cosine of x minus 1. Now, if we just let x tend to 0, in the numerator we have 1 minus secant squared of 0, which is equal to 1 minus 1, and this just equals 0. In the denominator we have cosine of 0 minus 1, which is also just equal to 1 minus 1, and again 0. So our limit is of the form 0 over 0 again, and we're going to have to apply L'Hopital's rule for a second time in order to solve this problem. Doing so, we have the limit as x approaches 0. Now, the derivative of the numerator is just minus 2 times secant of x multiplied by secant of x times tangent of x. All we've done is use the chain rule, so we've brought the 2 down to the front, multiplied that by the inside part, and then taken the derivative of the inside part, which is this. Now, this is going to be divided by the derivative of the denominator, which is just minus sine of x. If we just tidy the limit up, we have the limit as x approaches 0 of minus 2 times secant squared of x multiplied by tangent of x divided by minus sine of x. And notice we're dividing a negative number by a negative number, so we're just left with the limit as x approaches 0, 2 times secant squared of x times tangent of x divided by sine of x. Now, we have a tangent of x in the numerator and a sine of x in the denominator, and if we evaluate both of these at 0, we get 0. So the limit is of the form 0 over 0 again, and we're going to have to apply L'Hopital's rule for a third time in order to solve this limit. Doing so, we have the limit as x approaches 0, 2 multiplied by the derivative of secant squared of x, which is just 2 times secant of x multiplied by secant of x times tangent of x. And remember, we need to multiply this by tangent of x, plus 2 secant squared of x multiplied by the derivative of tangent of x, which is just secant squared of x, all divided by the derivative of sine of x, which is just cosine of x. Now, we could just go ahead and multiply everything out and tidy it up, but instead of doing that, let's just evaluate the limit as x tends to 0. Notice here we have a tangent of x, and tangent of 0 is just 0, so this whole term here just goes to 0. Secant squared of 0 is just equal to 1, so 1 times 1 is just 1, so we're just left with 2 here. And in the denominator we just have cosine of 0, which is equal to 1, so our final answer is 2. Thank you very much for watching. I hope you found this video useful. If you did, could you please make sure to like and subscribe, as it really helps the channel out. I hope you have a great day.